Basic properties of fluids problem solving. Problem number 1. What is the weight of a 45 kilogram boulder if it is brought to a place wherein the acceleration due to gravity is 395 meter per second per minute? A key in solving problems which requires various solutions or computations is to first know what are the given quantities of that certain problem. It will help the students in arriving for the best formula to be used in solving the problems correctly. For this certain problem, the given is a certain boulder which has a mass of 45 kilograms and a gravitational acceleration of 395 meters per second per minute. As you can see in the screen, it is required to align all given to its common unit. If you take a look at the certain given gravitational acceleration, it is not in its standard state because gravitational acceleration has a standard unit of meter per second squared. So to be able to arrive at meter per second squared, you have to multiply the given with its conversion factor, which is 1 minute over 60 seconds. And you will be arriving at gravitational acceleration of 6.58 meter per second squared. It is also important to know what is being asked in the question. So for this certain problem, what is required is the weight of that certain boulder at that certain state. As per the solution, the formula for the mass-weight relation is weight is equals to mass multiplied by the gravitational acceleration. As you have already aligned all the common units of the certain given, you may substitute it directly to the formula. It is also important to include individual units of that given to be able to come up with the correct unit of the answer to the certain problem. So for this problem, 45 kilograms multiplied by 6.58 meter per second squared will give you an answer of 296.25 kilogram meter per second squared or in newtons. Problem number 2. The specific gravity of certain oil is 0.82. Calculate the specific weight in kilonewton per cubic meter and the density in kilogram per cubic meter. There are problems in fluid mechanics wherein the given and the required differs in the system of units. For example, the given may be in English or CGS units, while the problem requires you to convert it to SI units. Remember that you can only use one system of units upon calculation. You can never arrive at the correct answer if you use two or more different system of units upon solving. So for this problem, there is a certain oil which has a specific gravity of 0.82. You are required to find the specific weight and the density. So jumping to the solution, you can only solve the specific weight if you use the formula for the specific gravity which concerns specific weight. So specific gravity is equal to the specific weight of the fluid over the specific weight of the reference fluid. Though not given, the reference fluid is always assumed to be water, unless specifically stated by the problem that there's a different reference fluid being used. So for problem number 2, since it's not stated, you may use the specific weight of water as our reference, thus giving you the specific weight of water as 9.81 kilonewton per cubic meter. Upon the substitution of the given, you will arrive with this equation. 0.82, which is the specific gravity, is equals to the specific weight of the fluid over the 9.81 kilonewton per cubic meter, which is the specific weight of the reference fluid. Thus giving you the answer of 8.04 kilonewton per cubic meter. Another quantity being required by the problem is the density of that oil. And again, you can only solve this problem upon using the formula for specific gravity, which concerns density. So it is given as specific gravity is equal to the density of the fluid over the density of the reference fluid. Again, since it's not stated, we can always assume to be the reference fluid to be water, thus giving you the density of fluid as 1000 kilogram per cubic meter. And you will be arriving with this certain equation. 0.82 is equals to the density of the fluid or the oil over 1000 kilogram per cubic meter, thus giving you the answer of 820 kilogram per cubic meter as the density